Everybody, so I'm Hussein Harake from the Swiss National Supercomputing Center. I'm actually going more or less continue what you started already because it's somehow similar. We'll be talking a little bit about the Lustre and about the DNE part. So she mentioned the performance of metadata, and this is, I believe, a topic we have been working around for a long time. So first, a couple of words about CSCS. This is at least the agenda. So a little bit about CSCS, we'll talk a little bit about Lustre, just very short description. We talk about metadata, then DNE, which is covering what we call the clustering metadata. And some of the results we have seen on running some tests on using the DNE. So if I don't mention CSCS, you will never send me again to here actually or somewhere else. So that's why I'll be just talking a little bit about CSCS. So we are located here actually. So I've never been in CSCS. This is all Switzerland, also it's small countries who are here down next to Italy. And you can see Como is there also. Somehow Milan is below a little bit. Where we speak Italian actually as a main language. This is the new building. We moved to CSCS new building in 2013, beginning of 2013, end of 2012. And when we organized the move, actually it was a very exciting project, moving data from the old buildings to the new building, and we had a lot of work done, and that all has been done over InfiniBand between two sites. And I had different talks about covering the move of data from one building to another. This is a slide showing the machine that the supercomputing of CSCS starting. Before I started, actually I started CSCS in 2001, and at that time the SX4 was in production. This machine, this one was the backup actually, and no I'm wrong, it was SX5 and the 4 was in production. Well, this one I did not see it, that was before my time. And with that, after this vector machine, the IBM came, and then we started the Cray machine. At the moment, our system, the biggest one, it's called BitsDyned, and the system is roughly 7.7 petaflop machine, and these are the rest are different clusters and systems. So this is a Cray, IBM, and Cray. The rest of these are clusters, and we have different variation of storage interconnects from Gemini to Eris. That's property of Cray, and a different InfiniBand kind of network. And this is a map for the InfiniBand network that we're using. So this is the one that connects all the cluster with each other, and running at the top of it there is a global file system. This is GPFS plus some computing going at the same level. So a lot of optimization is taking place there at the InfiniBand part, plus different clusters here. So if we count the InfiniBand clusters and we compare to the Cray, I believe the InfiniBand is just bigger. Also that the Cray system is somehow, the bigger in size. Okay, this is the machine room. So if you look at the building and compare the machine room, this is 2,600 meters square or square meter. And this is almost, you could play soccer or football, whatever you want inside. It's quite a big machine room. That's a nice part of how do we cool this system. This is we take the water from the lake, and what we call it the free cool water. These are two pumps actually just pulling the water from the lake, and they work at quite interesting speed. So we could talk about 700 liters per second. That's the peak of it, and we are running so far at roughly 400. That's continuous over time, and we are able to deliver the warm water around CSCS. So there are a lot of even we could just give heating water for the house also for free. There are different places where they can pull it. I mean, some of these projects are, but that's going to be free of charge, because we don't want to power on the machine only to provide hot water. Okay, that's about CSCS. I think I gave them enough time actually. So we'll talk about Lustre. A couple of words about Lustre. Distributed parallel file system. This client server. Available for Linux, POSIX. It scales. I think this is that time it was In the state, this is Jaguar machine, 2,600 nodes. And that was measured about up to 240 gigabyte. Pitch-Dine, actually, I tested myself, Pitch-Dine, and this we got 120, 124 gigabyte per second. That was a peak and write. High availability plus open source. These are some of the, let's say, the main points of Lustre. And if we take a standard Lustre layout, that's how it looks like. What do we have? We have an MDS, which handles the metadata, the MDT, which is the RAID or the device that holds all the metadata, plus the data servers, which we call them OSSs. These are the OSTs where they are located. So all that's in theory between the OSSs, the MDSs, plus the network, and there's a client. That's Lustre, full stop. And the rest is between. These are failover. This will just take over for this one, and this one will take over for this one. And the same for the MDS. And the good part of Lustre is just variation of allowing different kind of networks. So it's not only limited to Ethernet or to InfiniBand. That goes for different also kind of topologies. So if we look at the metadata part on Lustre, what do we have at the moment? We have one MDS server. This is a failover, and they are just active passive. One MDT, which is one device. Usually they are. I've seen sites still using 10 disks for creating one RAID, and this is used as an MDT. Just imagine how much you could get from that. So if you want to scale at the MDT, at the MDS itself, there are some issues, because at a certain point you will have issues with scaling. And so to have seen maximum performance on one MDT. So just even if you take out the disk, you put SSDs, fast one, whatever, PCI Express that could deliver 600K IOPS, that's what you're going to see. That's because of Lustre. So if one aux is not enough, what we will do? Okay, I buy a bigger one. I don't think that's a good solution actually. What we do, we buy two. And that's what we're trying to do. So if you look at the wiki of Lustre, they say that Lustre has been optimized in a very good way, that if your application is extremely needs a high load on the metadata part, what you do, you could just buy a big Sun at that time machine, or you buy something from Dell that has I don't know how many cores and how much enough memory inside it, and that's the way to go. That will bring us to a bigger aux, and that will never be the solution. That will be just maybe for this application, but the moment we'll grow more, I don't think you can just grow more than that. Maybe you'll have elephant maybe instead of auxes. But so what we do, we go for what we call the DNE, and this is what will, that's the, let's say the first part or first step of clustering the metadata. So what this is the first version, came out with 2.4, and I believe Maria also mentioned that before. So it allowed multiple of MDSs and allow multiple of MDTs per MDS or per multiple MDSs. So I could have, I believe the number is 4096 of MDTs per file system. So what you do, this is a root. That's the top level file system where you mount the file system. And then what you will do is you will just create a child directories and you map it to an MDT. And in this case, the first level will be writing to the default one, which is the MDT0, while the second one depends how do you map it. You want to send it to MDT1 or MDT2 or 3, and you can just go forward, just second, third direct, depends on the number of MDTs that you have. So that's our layout will change like this. In this case, our OSSs, they are still the same. I have multiple MDSs and multiple MDTs. And in this case, I could always continue with the failover between them, but they are just active. So this one will write here, and this one will write here. And in case I lose this one, I could write also to multiple of these. I think that's also missing one more or two or four, whatever, that for every MDS here, I just put only one, but we could have multiple of MDTs per MDS. So this is a system that we used when we run the test. At that time, we used the Dorado system from Huawei, and we had 2 OSSs only and 3 MDSs. That's InfiniBand, nothing special here, just that this system that we wanted to guarantee that I have from the hardware point of view that could deliver a really high IOPS instead of getting stuck here, and see how much we could reach running on Lustre. The OSS part is very critical, because the first test we did, we thought that we could just put 1 or 2 OSSs and that would be enough to be able to go for a high load on the MDTs. But that was a mistake, and we learned later. I'll just talk about it later. Here, that's also, it's not enough here to optimize here, but you need in parallel to optimize here too. And these are the number of clients. Okay, so this is how do you add a multiple MDTs. So nothing special about adding more MDSs and MDTs. These are the local, where I was just running just the MKFS of Lustre and telling that this is the MGS and this is the MDS, and the index for the MDT is 0. And this is the device where it's located. That's the first. This is MGS and MDS at the same time. The second, third, and fourth, at the same server, I have to indicate the IP of the server, and that's also has an MDT, and its index is 1 plus the device, which is LAN 2, LAN 3, LAN 4. Now the rest of the MDSs, I just go to that server itself and run it there. So this is called whatever, Grana 10. There are 4 MDSs, and then Grana 11, which has 4 MDTs. Sorry. In this case, in total, I have 12 MDTs here on 3 servers. And here how I map every directory to an MDT. And just using the LFS command, I create a directory and says the index for this directory is 0, which is the main one, the default one usually. Even without, I could just remove the -i0 and just tell him where the directory is. Then I call the second one, which is I map it to index 1, that will correspond here to this one, index 1, that I created before. And I continue until just I cover between 0 and 11, which is these 12 MDTs. So this is how I create when I create the file system, and this is how I map them. And here, just nothing special about it. So these are the first result running on 1 MDS, and these are the number of MDTs. And they are just, I used here the famous famous MDS, just creating files, creating multiple of files, this benchmark tools that you mentioned also before. But here I mounted only the file system once, and I had different discussions with many people as how you could possible to create using this benchmark tool on multiple directories while you are just only mounting it. So in the code itself, there are possibility to write to multiple directories using this benchmark tool. So it's not required that you need to mount the file system multiple of times. So there are just some syntax that you could add it to it, and then you can just write to multiple directories. And this is what we used here by creating files, stating them, and removing them per directories. So if I take one MDTs, the first MDT here, you can see just this is 50K, we are just roughly around 20, between 20 and 30. And then going to 2 MDTs, you can see just we are hitting almost, 47, then 50 and 55. That's using 1 MDS. Here we can see that 8, also I had before 4 MDTs, but that's the first run where I just added 4 MDTs per 1 MDS, and this is what we get. So you can see that there are some scaling especially on creating and removing files. Okay, the stat part I don't really care a lot about because memory is playing a lot there. And how we were just able to guarantee that these are the results, we have just been monitoring the system in different ways. One is that we see what the happening to the inodes itself. The second, we were just watching the hardware itself and see how much we are creating and removing on the hardware. So you can see IOPS on the hardware itself, that this is what's going on. Now for the file, that's for the directories. While the files here, you cannot, maybe you could just, it's somehow a little bit better between 45, 55, 60, and 75K. So that's again the same linear. This is one MDS. Now if I take two MDSs, we reach almost 60, and from there we continue. Two MDSs with 2 MDTs per every MDS, and you can see continue scaling. And here, this is for directories, this is for file. Again scaling, and we reach here 150K IOPS per second. And this is 3 MDSs. And if you look at the files, we are above 200K in creating files per second, and the same for removing. And these numbers appeared also on the device itself. So when you just see what's happening on the hardware, you can see that just going up and down in the same way. And the same for the inodes. You can see that it's creating this number of inodes and deleting this number of inodes going on in the live way. So I think that's going to be maybe my last slide, but I would like just to talk a little bit about this one, because there are a lot of things that we would like to share here. Especially that the first thing is the amount of memory per MDS. So the first test when we were running, we're just trying to go for a bigger number of MDTs per MDS. So I believe we went up to 16 and even 32. No, 16, that's where we had some crashes. So the MDS just crashed. And then we had just power cycle it. And after some time, we figured out that the amount of memory, it was a big problem. So it had 64 gigabytes, and we just upgrade that to 128, and the crash disappeared. So that was pure memory. So the MDSs are memory hungry, and that's you always need to have to guarantee that if you want to add MDTs, you need for every MDT 16 gigabyte of memory. As a minimum for a server is 32. That's for the memory to avoid any kind of crashing, because then you'll have the crash and there will be no very little information about what happened in the server and why it just had this big crash. So the number of OSTs, and this is again a second problem we have seen. So when we start running on the test system, we were just hitting roughly less than 100K IOPS, and we were unable to increase that. And at a certain point, just flicked in mind that, okay, let's try to add OSTs. And we found that in every time we add an OST, the IOPS on the MDSs, on the MDTs is increasing. And the reason for that is that when I'm creating 200K of files, these files are located on the OSTs. And it's only how they are linked, the attributes, the permission, and all this information on the MDT. But that means you need enough OSTs to handle creating all these files. And if you don't have enough OSTs, or you don't have fast ones, then you will face the same problem where you'll just be hitting a certain limit and it will not increase anymore. So that's why we had to go for, at the beginning we had to add OSTs, and then I removed them and start putting SSDs for the OSTs only for testing, and that really improved a lot the situation until we get this number. So 200K, what we reached, I believe it's still something we could do to improve that, but this is what we got so far until now. So again, back to the DDN presentation, when you showed the tools delivered by Lustre. So Lustre had different tools like OBD filter and metadata survey, and this is usually for the OBD filter. What it does, it only measures the speed of the disks. So it doesn't hit the network, it runs only on the servers, and it measures how much you could get bandwidth to all the disks and the devices itself. Now the same for the metadata part. They have a tool also that could measure how much you could reach metadata. The problem of at that time when we tested it, all the tools that had to do with the DNE did not work, and was crashing the MDS. Just simple. You run the first command. If you run on one MDT, that works. You touch two MDTs, the system will just, the MDS will just crash, and you have to power reset it. Now we tried a different combination by running two MDTs in one MDS. We tried one MDT per MDS, and all kind of combination that did not help. Anytime you touch the second DNE, the second MDT, that's it. The server will crash. I believe that I reported that at that time to Intel, and there were bug filled up, and they think that should be solved now with 2.5x. I believe 1 or 2 is out and should now be fixed already. So there are some limitations on the DNE, and this is not the end of what we'll be doing. So this is the first phase, and let's say this is the first step for clustering the metadata, and the goal is just to go for this. We'll be testing the DNE2, I believe, in very soon. We have some access to these new codes, and that will allow us to run some more tests with the second generation of it. So for instance, some of the limitations of this DNE is that root is the only allowed user to create remote directories. So users cannot create, even in home directory, he cannot create a directory and tell it to map it to a second MDT. So root has to always do it for the user. If you have a problem, for instance, with a second MDT, you cannot check it. You cannot run any kind of Lustre fcheck because it doesn't have this. It doesn't work so far. Plus migrating metadata. So if you just upgrade to, you want to use DNE, that means all your files and data that are already available, you have to copy them. You cannot just say, okay, migrate these to a second MDT, because it's still, you need to copy them. That means to be able to move them. So these are kind of limitation on this version, and based on what Intel promised or let's say not only Intel, also the community of Lustre, that the second generation should allow us to have a tool for migrating, and we will have a tool for checking that these devices are fine. We'll have also that users will be able to create, is allowed to create these directories. Plus the main one is that you will have somehow a share between the metadata devices, which is the most important part of the DNE generation 2. Now I have to create a directory and map it to a device. There you'll be able to share between them, hoping that one day we'll be coming to a striping metadata, which is, it will come one day, I believe. I know that many vendors thinking about striping metadata. Striping data is not enough, but striping metadata could be also helping somewhere in the future. That's it.
Any questions for Hussein?
So I missed a bit. I'll get answer you on. I missed a bit. You said that some applications failed on DNE. This is DNE 1, right?
This is DNE 1.
And what was the cause of that?
No, I mentioned that the failure of the DNE 1 we had, it was multiple failures. The first one was the amount of memory per server, and especially when you have multiple MDTs. So you need at least, based on a very basic calculation, 32 gigabyte per server for one MDS and one MDT, and then you add 16 gigabyte of memory for every MDT you add inside. And I think the number you could reach is quite a lot per server. That's one case. And the second failure we had was on the benchmarking tools that comes with Lustre. When we are just touching the second MDT, the MDS will crash. That's with the old version. I believe that's solved so far with 2.52.
Any others?
Okay.
All right.
Thank you.
Thank you.